So in order to tell whether the material properties, first we have to see the grain boundaries. So by not doing any mechanical characterization, we can say orally whether it is having ductile nature or the brittle nature by seeing the grain sizes. So like industry people, how they are going to decide by seeing the grain sizes, we are going to do the same. So it is like one of the material characteristics. So here we are going to perform the grinding. So grinding is the material removal process. There we are going to remove the material step by step. So first we are going to use the emery paper sheet of high number. So high number means the number of grains here per square inch will be less, because now bone from small to higher we will go, right?
Yes. First
We will go from smaller 400. So the number of grains per square inch will be very less compared to the P 1200. 1200 means the number of grains accommodated will be more. The number of grains accommodated for P 200 will be very less. So the surface roughness will be very high. So you are going to do the smoothing grinding process by holding the specimen like this. So you have to do smoothly with one direction. Then you're not supposed to retrace the specimen back, so it will damage the surface. So again you have to lift the specimen and again you have to perform like this. So like this you have to do for 2 minutes. So most of the surface roughness which we cannot see through naked eyes will be removed. So we can get the flat surface by doing the low emery paper number. Then after you tilt the specimen 90 degrees, then again do it. So
all sides we have to do.
Sides. No, one side only.
Okay.
One side,
but 90 degree we have to,
will be enough.
Okay.
90 degrees. On the same surface you have to rotate it. 90 degrees 2 minutes. Then rotate 90 degrees 2 minutes. That's all. 2 times. So then after maximum surface roughness or the wear debris will be removed. Then you go for the next emery paper. Higher emery paper. There we are going to do the furthermore smoothing by doing 2 minutes like this, then after doing 2 minutes like this. So it will give much smoother. To go for much smoother, like mirror finish, when you are going to see your face on the mirror, when it is very smooth or flat, then only you can able to see your face on the mirror. So it can reflect the light back to your retina. Otherwise it will diffract from one place to another face because of the holes or the valleys and peaks. So it cannot retrace back to the original shape. So it should be flat and mirror reflected to see the microstructure. So further we are going for the much higher emery paper size, 1200. There we are going to get the mirror polish. So there you can see your face also by doing this. Like you can get very smooth surface. No need to apply one pressure at one corner. So it will make the surface inclined. So there the light won't come back to the source. In that case you have to apply gently and uniform pressure you have to apply. You have to do the smoothing process. So once you done this, you will get the flat surface. Then again we have to clean the surface. The aluminum box will be. So you have to dilute the aluminum paste in water.
Okay.
With bottle. So you have to pour in between each 5 to 10 seconds. You have to apply one direction first for 2 minutes, then rotate and apply for another direction. So polishing is going to complete.
Okay. So
here
we have to put here aluminum.
Yeah, we have to put aluminum, not the lubricated one, diluted one
with water.
Put. So you have to apply each 5 seconds or 10 seconds. So you have to apply for 2 minutes, then rotate and apply for 2 minutes.
Okay.
So here polishing is going to complete.
So first grinding, then polishing. Speed
very low speed.
200
RPM is fine. So here once it's done, now whatever you are seeing is like a plain wall. Maybe you can show. Plain wall. So here you cannot see the bricks and the cement. Like here also we cannot see the grains and grain boundaries unless until we do the etching. So etching is nothing but removal of the layer or the burning of the layers. So here the grain boundaries are the weaker ones than the grain ones. If you do the etching, the acid will react with the grain boundaries. It will becoming like a separate bodies.
Okay,
It will separate the grains and grain boundaries
Hmm.
in the microscope. You can see easily.
Hmm.
So here for the etching we are going to use nitol.
Hmm.
So nitol is nothing but
Hmm.
nitric acid plus ethanol combination.
Hmm.
So nitric acid 10%, ethanol is 90%.
Okay.
So you have to dilute the liquid.
Hmm.
Like
Nitric acid 10%
uh,
and ethanol
ethanol is
remaining
90%.
90%. Okay.
So you have to mix the liquid and you have to dip for 15 seconds.
Okay. Okay. 15 seconds only. Okay.
15 seconds,
Hmm.
then you remove it.
Hmm.
Then once you remove it,
Hmm.
then you have to
Hmm.
clean the surface with tissue paper.
Hmm.
Then you have to go for the microstructure step. This is the metallurgical microscope. Here you are going to keep the specimen. So for that you have to turn on this equipment. So once you turn on this, a blue light will come here. It is not turned on.
We will open material plus.
Material plus.
Okay.
You keep the specimen and adjust the thing, but you have to see the camera, right? You go to start capture. Okay. So live display. So whatever the thing it is showing here, it will come here. So if you not see the screen, you adjust the lenses,
Okay.
top and bottom, left and right.
From here.
Anywhere. Okay.
Okay.
Here and there.
Okay.
Okay. Once you saw the screen clearly with the grain boundaries like this, then you start capture here. Capture frame. So it will save as a image here.
Okay.
Then that image you save it. So now you have to perform some calculations. That's all. Here we are not going to do anything much more.
Okay.
So here once it done, you take the images. They have to do certain procedure. That I will explain with the help of some image. Okay. So this is the image. Do you know what scaling it taken the image? You don't. So for that, what you have to do is you have to download some images software. Images we have to download.
Yes. Now we start from the beginning. Okay.
Go to this first link itself. Go to image J. This is the software. There we are going to do everything. So here yours is Windows, right? Windows. Go to this Windows. Download. If you upload any new image, whatever the line you are going to draw, what is the distance between those 2 points? How would you know? Because with this proper scaling, whatever the scaling
This is 100.
here,
Okay.
you have to go analyze, set to scale. Okay. Set to scale. And here you have to draw a line also. First you have to draw the line. Okay. This is the line. Okay. Here from this point to you press shift. It will come straight. Okay. Done, right? Then you go to process, analyze, set scale. Here known distance. This is the pixels distance. Okay. 61.833 pixels it measured. But what is the distance of this many pixels?
100.
You know that known distance 100. So pixel ratio 1 only you are giving. Okay.
100.
You
We
need
have to give 100, na?
here known distance. Sorry. I given.
Number lock.
Okay. So in known length it is micrometer, right? You just type UL micrometer. Okay. Then apply to global. Then press OK. See here now if I draw any new line, okay, shift. Okay. Maybe this is off, right? Off. So here it is showing the length.
Okay.
52.
52. Okay.
So this is the 52 micrometer length. So now what you have to do is you have to zoom on this. Now the scaling we given. You zoom out. Zoom out. Okay. So now how to measure the grain size means you have to select a box, a rectangular box with this one. Okay. So
from where you selected? From line only.
Anywhere. Okay.
No, which command?
This is
Okay,
the
this
one.
command. Okay.
Okay. If you click it. So here you are drawing the rectangular box, right? So if you don't click anywhere, don't click anywhere new places. So here, whenever the box is visible, you go to here. So it will show the dimensions. Width is 346 micrometer. So height is 195 micrometer. So whatever the box we given, width is 346.09 micrometer. Height will be 195.69 micrometer. Okay. So now you have to count the number of grains inside the box. So if you see any full grain, that count as a 1. If you are seeing any half grain which is crossing the boundary, count as a half. So off, this also off because it crossed the boundary. Off. 1, 1, 1. Like that you have to count the total number.
Okay.
So how many offs plus? So for example 10 half grains plus 5 full grains. So it will be coming 10, right? So 10 number of grains for the this much area.
Okay.
So now you have to count what is the number of grains will be there in the 1 square inch. Convert the units. These are micrometer, right? So 1 square inch having how many micrometers? That proportion you calculate. It will task for you.
Okay.
Calculate. So per square inch.
Number of grains
number of grains will
per
come,
square inch. Okay.
you have to
So
calculate.
square we have to convert in a square inch.
Whatever it is.
Okay.
Okay. You have this is inch also you can calculate.
Okay.
That is better. So this also.
So that
inch.
how much number will come?
Number
Suppose
will come. For example, we will see. I didn't remember exactly. Once I get the image. Okay. Steam grains which chart. There is some chart. Okay. So there is grain size formula is there. Capital N equal to 2 power small n minus 1.
Grain size is equal to 2 to the power n minus 1.
Minus 1. Okay.
So what is n here?
That's what I have to see. I don't remember. This whatever we calculated.
Grains per square.
I think it is capital N.
Okay.
Then from this you have to get the small n. Okay. From this chart.
Okay.
Maybe I will share the chart. It's in PPT also. So if you go to that number, nearest integer, it can show you the grain size, diameter, average grain diameter from the chart. You can pick. So whatever you calculated per square inch is capital N. So if you substitute.
So you write here, na, capital N is equal to this thing. You write here, na?
Yeah,
it will be clear.
Capital N equal to 2 power n minus 1.
No, what is capital N? You write here, na? What is capital N? Just
number of
grains which we have calculated per square inch.
Grains per square inch.
That is capital N. Okay.
Capital N.
From this we will calculate
you will get
small n.
ASTM grain size number, small n.
So a small n is
ASTM
grain size number. Okay. And after that, ASTM grain size number.
Go to chart.
Okay.
Use
this one
for small n.
ASTM number. So from
ASTM
here we will
number.
get
the last one.
Last
grain
one,
size
average
diameter
grain
in
diameter.
mm.
Okay.
So average grain size diameter you can get.
Okay.
So that's the procedure.
Okay.
Apart from that, nothing.
Okay.
So they have to select 3 areas. Because one area you cannot conclude, right?
Okay.
So 3 areas they do the averaging. They can report it.
Okay. So what if high that this one comes? High, some meaning is there, high, low. If number is more or.
No, that I don't know.
Okay.
That's all we are going to report the ASTM grain size.
Okay.